Okay, this is the 2.7 pre-notes for the class that's going to happen on Wednesday. So we're looking at inequalities that have not an x to the first power, but x squared or higher and them. These cannot be solved as simply as the linear inequalities, which were the ones that had x to the first power. The reason is when you can factor something, there's just more than one piece that's going to affect your sign, which will determine whether or not you're going to be greater than 0 or less than 0. So what we have to do here is we come up with first of all, we factor everything. Then we come up with a list of possible places where you could equal 0. And then we do test points on each side of those numbers to see where is our inequality either positive or negative. So that we just look for those sign changes. So that's kind of a summary recap of what this is going to be. And of course, we'll write our answer in interval notation. So here's my rules for this. Make sure the inequality has 0 on one side. That makes everything easier. Find the real zeros. That means you try to factor, or if it doesn't factor, you might have to use quadratic formula. Use the zeros to break the inequality up into regions or intervals. That's what I was talking about, but we're going to make a chart. You choose a test value in each interval. You can find the corresponding f pound, that means plug in the number to the function, or another option here, and one that I'm actually more fond of, this was just from the book, I just look at how the test point affects each factor. And I'll show you what I mean by that. Interpret whether or not your value is true or false. That means if you're looking for less than 0, you want negative answers. If you're looking for greater than 0, you want positive answers. Anything that fits your description of true, which means did it fit the inequality, would be an interval notation for you. Okay, so let's try some of these. They're not that bad. So first of all, get 0 on one side. So subtract that 4 over, you get negative 21, less than or equal to 0. Because this has a 1 in front, it's going to factor pretty nicely. Factors of 21 that have a difference of 4, since this is negative, would be 7 and positive 3. So negative 7 and positive 3. And then we don't actually, we still set it to equal to 0 to solve, but these are called critical values. They are places where you possibly could change from positive to negative on your inequality. So first one would be 7 from the first parentheses, and the other one would be negative 3. So here's where I was talking about we do kind of a test value thing. I actually draw a number line. I put the test values or critical values here on the number line, always from least to greatest. So we'll list negative 3 first, then we'll list 7. I then mark whether or not this is open or closed. I use the circles here because it's easier to see. So because of the equal to bar, these both are actually where I equal 0. So they are part of my solution. The question becomes picking a value on each side of these to see if each region is true or false. So something smaller than negative 3 would be negative 4. Anytime you go from a negative to a positive critical value, always try 0. It's easy to plug in. And then 8 would be bigger. Okay, so these are what we call our test values. Then we're going to actually list out our factors right here. Okay, so our factors are, we have an x minus 7 and an x plus 3. For each one of those, you're going to ask, does this make it positive or negative? And then once you figure out all of your factors, you look for what we call the overall sign. So negative 4 minus 7 would be negative. Negative 4 plus 3 is also negative. This is multiplication, so a negative times a negative makes a positive. 0 minus 7 is negative. 0 plus 3 is positive. A negative times a positive is negative. 8 minus 7 is positive. 8 plus 3 is also positive. A positive times a positive is a positive. Once you know your signs, you go back over here and you say, okay, do I want to be negative or positive? Less than means our final answer should be something that produces a negative. If that had been a greater than, we want something that produces a positive. So this is going to be our region that works. Now this region, and this is why I did the closed circles here, is negative 3 comma 7 with brackets on each bar because we could equal 0 at either of these values, and we did have an equal to bar. So that's my first one. So this is my answer right here. Let's look at another one. This one gets people because they just try to they say it's already factored, but it's not equal to 0. So you have to undo their factoring by distributing that x and moving the 4 over. So 3x squared minus x, and then subtract the 4 over. This is going to be a factor by grouping one, so I'm going to do some scratch work up here. 3 times negative 4 is negative 12, and factors of negative 12 that make negative 1 would be positive 3 and negative 4. So this would be 3x squared, so I'm doing factor by grouping, plus 3x minus 4x minus 4. Pull out the 3x, that would leave me with an x plus 1. Pull out a negative 4, I also get x plus 1. So it looks like this guy factors into an x plus 1 and a 3x minus 4, and we want it to be less than or equal to 0. I just call critical value CV from this point. Negative 1 would be 1 because that makes this 0. This one might be a little harder to visualize, so imagine setting it equal to 0, adding 4 over, and dividing by 3. So my other critical value is 4/3. We come over, we make our number line. You have to make sure you write them from least to greatest. So negative 1, 4/3. Again, it had an equal to bar in the original problem, so these are closed circles. Pick some test values. Negative 2 is smaller than negative 1. 0 is between these two numbers, and this is 1 and 1/3, so positive 2 is bigger. List out your factors. Our factors were x plus 1, 3x minus 4, and then once we know those, we want to get an overall sign. So negative 2 plus 1 is negative. Be careful with these. You may have to work a little bit more. Negative 2 times 3 is negative 6. Minus 4 more is still negative. Negative times negative is a positive. 0 plus 1 is positive. 3 times 0 is 0. Minus 4 would make that negative. 2 plus 1 is positive. And 2 times 3 is 6. Minus 4 is also positive. So this comes out as a negative overall, and positive times positive is a positive. Again, I'm doing a less than or equal to, so I do want the negative case. So this would be answer negative 1 to 4/3, and brackets on both because of the equal to bar. Okay, let's talk about this one. If it was me, I would probably move everything over to the right side because x squared is positive over there. And then after doing that, I might still rewrite it so it looks normal, just realizing that this opening needs to go towards the polynomial. So this one factors into x minus 4 and x plus 3. This time we're doing greater than or equal to. So my critical values are positive 4 and negative 3, because that's what would make each of those 0. We would place negative 3 first numerically, and then 4. Test values would be something smaller than negative 3, something in between, something bigger. My factors are x minus 4 and x plus 3, and I want an overall sign. Okay, so negative 4 minus 4 would be negative. Negative 4 plus 3 is negative. Negative times negative is positive. 0 minus 4 is negative. 0 plus 3 is positive. That would be an overall negative. And it does not always go positive, negative, positive. We've had 3 of those back to back. Trust me, that is not a common thing. Even the signs don't even have to alternate. It could be positive, positive, or negative, negative. But those cases are a little bit more rare. 5 minus 4 is positive. 5 plus 3 is positive. Positive times positive is positive. And we are, again, including the endpoints because of the equal to bar. This time we wanted greater than or equal to, which means the positive cases are the answer. So since I have 2 of those, I would have a union. Negative infinity, because that's the farthest you can go this way, up to negative 3. Union with 4 to positive infinity. Okay, we have one more on the PreNotes. Move this over so that you have 9 over with the 16. So this is perfect squares. So square root of 16 is 4, square root of 9 is 3. So one case we write it with a plus, one case we write it with a minus. We still have greater than 0, not equal to. This would be negative 3/4 for a critical value because you would subtract 3 and then divide by 4. And this one would be positive 3/4. Place those on your number line because we're trying to see how the signs are going to behave. Test values, I would say -1, 0, because this is between those two, and +1. And you can pick anything you want. I'm just picking things that are pretty close so that my numbers don't get too big. So then I have 4x plus 3 I need to check, 4x minus 3, and then I need to know my overall sign for each part. Okay, so -4 plus 3 would be a negative. -4 minus 3 would also be negative. Negative times negative is positive. 0 times anything is 0, so that'd just be +3, which is, a positive. 0 times this is 0, minus 3 would make it negative. The opposite sign would be negative. 1, and that would make that still positive, and then 4 times 1 is 4 minus 3 is still positive. This time I'm looking for greater than, but not equal to. That means these are like open circles, not closed, because they don't have the equal to bar. So this would be negative infinity to negative 3/4 parentheses, union 3/4 with a parentheses to infinity. I have 2 more of these that we'll do in class together on Wednesday, but I figured that getting a jump start on some of the examples might help speed that a little bit along. So that is the end of the 2.7 pre-notes.